So today's lesson is graphing tangents and all of the reciprocal graphs. Okay, so in example 1, we are going to graph tangents. So again, we're going to focus on the base function of tangents. So far, we have done sine and cosine. In order to graph tangents, there's a couple of things we need to remember. Let's draw some notes here on the side of our page. In your current workbook, this is lesson. So right before the word problem. If we have a right triangle, it is opposite adjacent, or the ratios it is sine cosine. What I'm going to do now is make x, y graph. So now we are graphing tan of the people on the y-axis. We're going to graph the height of tangents on the y-axis, and we're going to track the angle on the x. It's obviously going to start a graph of 0, 0. And we can, let's just think it up. Let's do two boxes on the circle. Let's go by 5 by 4. Every 2 boxes will use 5 by 4 for I'm going to use all of the things that we've learned so far and put them together. A tangent is a reference to any kind of chord. Tangent actually represents the slope of the line, or the slope of the as it moves. Because sine represents my y value for the height or the rise. And cosine represents the x value, which is the horizontal or the line. The tangent is the slope of these things as we go around. Now, let's take a look at what is the slope all the way to the circle. If we are at 0 degrees, we are on the axis, the coordinates 1 and 0. What is the slope at the point 1, 0? How do you sine over cos? In other words, it is 0 over 1. 0 divided by anything is going to be 0, right? So sine at tangent at 0 degrees is 0. This is our second word. Then let's go to the halfway point between 90 degrees and 0 degrees. Or you can say between 0 and pi by 2 is going to be pi by 4. What is tangent at pi by 4? You can either use the slope or you can use the triangle. Tangent at pi by 4. What? Right? Because we're using this part here. Opposite over pi by 4. Opposite over adjacent. Okay, what happens when we are on the y-axis at the point 0, 1? What's right here? What would be my fraction? Minus 1 over 0. We have a 0 in the denominator. This is minus 1. Think back to unit 1 and 2. When we had a 0 in the denominator, what did that represent? A non-permissible value. Representing what? Close. All of those things. Yes. It represents an asymptote, right? It represents a point that you are not allowed to touch because you're not allowed to have 0 in the denominator. So at pi by 2, we have an undefined or an asymptote for tangent. So where's pi by 2? Right here. So we have a horizontal asymptote. We can be slightly to the left or slightly to the right. Okay, what about between pi by 2 and pi by 4? What if we go like slightly before it? Let's call this pi by 3, right? Or in other words, 60 degrees. So we're past the 45 degrees, we're past the halfway point, but we're not quite at 90 degrees. Pi by 3, think of our special triangle here. Pi by 3. What is this tangent? Pi by 3. It's square root 3, right? So tangent of pi by 3 is square root 3. Is this number going to be bigger or smaller than 1? It's going to be bigger than 1. Okay, so this means between the halfway point and my asymptote, I'm going to have a number that's bigger than 1. Is it bigger than 2? No, okay, so it's gonna be somewhere like this. So I have a graph that's going to approach the asymptote in the positive direction. As I get closer and closer, right, I'm going to zoom in on my circle here. Think of this tangent as the slope. As I get closer, that slope is getting steeper, steeper, and steeper, bigger and bigger and bigger. So it's approaching infinity as I get closer to that vertical asymptote. Can't touch it, but I can get really close. Okay, what happens if I go past pi by 2? I'm going to cross the boundary, and now I'm going to do 6. Communicate without having to calculate it. What kind of a slope is this going to be? Positive or negative? Rise over run. It's going to be negative, right? So it's pointing down and to the right, or up and to the left. So one of the numbers is positive, one of the numbers is negative, right? Because in the second quadrant, minus positive, so this is negative. So I'm going to have a positive over a negative. So all of them on this side are going to be negative numbers. Now tell me, is it going to be a big negative number or a small negative number? Compare it to these lines here. Is it going to be like negative 100 or like negative 0? Asking about the slope. Those are the species. Another way you can think of it is slope is how far is it to walk up the hill? Harder it is to walk up the hill. Smaller the numbers. So very difficult compared to this slope. Very difficult. Right. So after pi by 2, I'm going to have a negative number that's very, very big. So after the asymptote, I'm going to have some kind of negative number here big. And as I approach, what is this here? As I approach pi, my numbers get very big here, getting closer and closer to what value? Smaller, smaller, smaller. Now, what points are these zeros? Okay, so once I get back to 180 degrees, I'm back at 0. So where is pi? At pi, I'm back to 0. I am at 1 at 3 pi by 6. Halfway between 0 and 0. Exactly between 0 and the asymptote. Exactly between 0 and the asymptote, I'm going to be 1. So the value of 1, but negative 1 in this case, right, because we're on the negative side. Okay, rather than going forward, because I've run out of room on the positive side, let's go back to the beginning and go backwards. We understand this pattern now, right? When we have a horizontal line, our slope is 0. 0, 5, 5. All of those are going to be 0. When I have a vertical line, that means my denominator, my sign value is 0, but place value is 0. Have it. So that means pi by 2, 2 pi by 2, and that goes pi by 2, pi by 2. And anytime I get a vertical, I'm going to have, yes, then coming from the top of the third point. I did not plot it at 3 because at somewhere in between here, you said it was going to be this 3. If you put that in your calculator, it says 1 something. So it's slightly bigger than 1, but slightly smaller than 2. But this oh, again, sorry, that was an estimate. That was just to point out that we're going into negative. That this slope is a big number, but somewhere down, negative side. Okay, let's go backwards. I know that at 0 plus 2 pi, I'm going to be 0. And I know that halfway between 0 and 2 pi by 2, or 0 and negative pi by 2, I'm going to have the value of 1, right? So halfway between 0 and 1, so I'm going to have the value of negative 1. Remember, only cosine is positive, not plus. That means all the way on. And then as I approach negative pi by 2, as I get closer and closer and closer, I get more heat. Okay? So my number is getting bigger as I get close, but I'm bigger in the negative direction. I'm going to keep the pattern. And then kind of looks like a cubic function. Not exactly, but you know, every time the line moves on the y-axis, every time the line moves on the x-axis, we have it okay? To the right of the 0, we are going to go moving up. To the left of the 0, we're going to go. So this is the general, it's based on the slope of the line. Okay. All right, let's talk about some key features of our tangent graph. What would be our maximum? We have an end point. No. So tangent goes on and on forever. So the maximum value. What about my minimum value? Same, but no. Do I have an amplitude? Do I have a wave? No, I don't. So amplitude, not a wave. I don't have a wave that's oscillating now. I have a curve. What about the period? The distance between key points, or the distance between the rotations. I've graphed for you three rotations. The main one is in the middle, that's the one we're worried about. But we do know that tangent is a rotating function, which has condensation on the surface. What is the length of one rotation? Yes, and if you're measuring one side, this goes from 0 to pi by 2. So it's pi by 2 on one side. However, the rotation has a lesser delta. Pi by 2, so pi by 2, period per second. Another way you can think of it is what's the key point here? The 0. What's the key point on this surface? So between the two zeros, where are the atoms? The difference between two and we can do atom to atom, or we can do zero. Just like this time, this time, you can top to top. Okay, where are the asymptotes? Pi by 2 and negative pi by 2. And if I go around the circle again, will I end up at another asymptote? So how can we identify plus pi? I'm not going to do plus minus because n is an integer, which means n could be plus. What is the distance between the asymptotes? Where is the first one? Plus or minus pi for the direction. Okay, so pi by 2 is my first asymptote, and I can go backwards or forwards pi, or again, think of it this way. I can start on the y-axis and I can rotate 180 degrees in either direction and end up back on the y-axis. So the asymptotes are at pi by 2 plus pi. What about the domain? This one has a restriction. Where is tangent allowed to be? We're going to focus on just the main and how do I write the domain? What are the allowable now? Has to be between the. And what about the range? This is something that's different between sine and cosine. You could have any x value, or their range was restricted between 1 and 1. Here, your domain is restricted, but you're allowed on these. Okay, x intersect. What is the pattern for this x intersect? Where is tangent to this? Think about where it starts. At 0. Where's the next 0? There's the next 0. Okay, next 0 is How do I write that? You're not wrong. How do I say every time? Oh yeah, yeah. Where n can be any number. N can be 0, n can be 1, 2, 3, 5, plus, or minus. Yeah. Okay. So these are the key features you need to know. You need to know the general shape of a basic system. And we have time, so we can get so we're going to do the cheat sheet so you can study off of, and we're going to do the practice question without looking at it. All you're really need is the little circle and the two signs, right? You can write it down on your test. We'll practice memorizing next week. We're going to have 3 days together and we'll practice that. Okay, let's go. Look at page. 1, 2, 3. You got 3 examples. Okay, in I think it was lesson 2, we talked about reciprocal graphs. This is cosecant. What is cosecant? What is it related to? 1 over sine. Good. Cosecant is the same thing as 1 over sine. So what we're going to do is I'm going to start with the sine function, and then we're going to do the reciprocal. Essentially, just put it under 1. Okay? So let's do the central x-axis here. Let's do I don't know, let's start with the center. Okay, let's go up by 2 squared is 1. 1. So every 2 squares on the vertical will be 1. Every 2 squares on the horizontal will be 5 by 2. Just like how I'm going to do that. 2, 5. 5 by 2. Okay, without looking at the board or at me, let's look at your paper and steps to find the function. Without looking at me or the board, where does time start? Let's go. This is math line. Okay, this is sine of x. What we want to do is check what is cosecant. We're going to take all of the numbers and go 1 divided by that. Okay? Let's start with the center. If sine is 0, what is 1 divided by 0? Asymptote. Yes, okay, so we can't touch the middle. Can we touch any of the other zeros? So anywhere where you see an x or x intersect, these are now vertical asymptotes. And on, I try to do it. Okay. Can we divide by 1? Okay. What is 1 divided by 1? 1. So, what about negative 1? What's 1 divided by negative 1? Also negative 1. Okay, so these points are all the same. Now we've got to look at something between all of the in-between numbers are going to be smaller than 1. Can you guys grab the calculator? I want you to test some numbers. 1 divided by 0.9. 1 divided by 0.5. 1 divided by 0.2. In decimal form, what do you get? 1.1. 1.2. Okay, can you do 1 divided by 0.001? Oh, okay. Let me back up. Let's start again. 1 divided by 0.9 is 1.1. 1 divided by 0.5 is 2. 1 divided by 0.2 is 5. 1 divided by 0.001. Okay, so this is telling me as time gets smaller and smaller, what is happening to coefficient? Okay, so sine goes small equals coefficient goes big. Okay, so now let's go to our graph. As sine gets smaller and smaller, coefficient is going to get bigger and bigger. So they both start at positive 1, but they're going in opposite directions. Okay? Sine gets close to 0 and touches it, but coefficient cannot touch 0. And so it gets bigger and bigger and gets very close, but not. They go in opposite directions. Does that make sense? Now that we've tested it out with some numbers. So sine getting smaller, coefficient, and they're getting bigger. Okay, so hopefully you can see the pattern. Sine graph going small, tan graph must be getting bigger. And we'll opposite. They are reciprocal rates. Only difference now is we have not crossing. Okay. Now at the bottom, if I make all of these numbers negative, what's going to happen to the other side? Will the numbers change? No, but they will become negative, right? So if the sine values are negative, then the coefficient values are negative too. So that means here, from negative 1, sine is getting close to 0, but it's negative. That means coefficient is going to go big numbers, big numbers. Okay, so coefficient is related to sine. If you know what the sine function is, you can graph the coefficient function. That's intercept the asymptote, and then all the stuff in between is just going in opposite direction. Could also just start to get wider. Yeah, so if I said let's add 6 to this, I would just take this point and move it up 6, take this point, move it up 6. The transformations all work the exact same way. You just need to know where is my starting point. Asymptotes move with translation. So if you're moving up or down, it doesn't really matter. So asymptotes only move with horizontal shift. Vertical asymptotes only move with horizontal shift. If they're stretched, they're wrong forever. So making it taller is fine. Even that's wrong. A vertical line lays on forever. So anything that affects the vertical is going to affect. The only thing that's going to affect it is if I start moving it backwards. Again, we will do examples today. Okay, domain. What is the domain of patient? How would we write this? How restriction? How action? How can I write? Greater than 0, less than 5. Range. This one has range restriction 2. We're focused on the blue highlighted graph. What is the range of the blue highlighted graph? Yeah, I have to be greater than or equal to 1 because I could be 1. Or that's the top half, how do I write the bottom half? Or less than equal to 1. How long is one rotation? Because it's next. Pi is the length of one loop. It goes up, down, up, down, up, down. So the distance between the two ups or the distance between the two downs, then the distance between the two ups is same. Okay, and asymptotes. What's the pattern for the asymptotes? There are. Yeah. Ready for the next one? That is just for the initial one. Yeah, it just kind of depends on where you are. Okay, here's another way you could do the domain. Between n pi and n pi plus 1. That's another way. This would be the general way. So between a pi and the next pi. That's all that matters. If I scroll, okay, so we're going to do this one here. Okay, C10 is related to which trig function? What is it? 1 over cosine. So we're essentially going to follow the same pattern. So let's get the cosine first. And I'm going to use the same scale as before. Perfect. Cosine. Right. F doesn't change. You still cannot divide by 0. And as the original value gets smaller, taking 1 and dividing by those values is going to get, and that doesn't change. So I don't have to rewrite all this. I can now focus on the cosine graph and know where all the asymptotes are. I look for an x-intercept if there's my asymptote. Where that cosine passes through. Then I have a value of 1. 1 divided by 1 is still 1, so there's 0.3. 1 divided by negative 1 is negative 1 to the bottom, so my starting point. And then going off of the starting point, as cosine gets close to 0, tan is going to go in the opposite direction. Just like it is. So this is good. What do you notice is the difference between sine, cosine, and they're both ways. What's the only difference between the central, not quite the central axis? So axis is 0 on the asymptotes are different by how much? Pi by 2, right? Sine and cosine are essentially the same. It's just insisted over pi by 2. Cosine starts at the top of the graph. Sine starts in the center. It's when you go over pi by 2 is at the top of the graph. So very, very similar. So all that's going to be different here is essentially where am I allowed and not allowed to be. My domain now is going to be between negative pi by 2 and positive pi by 2. My range is going to be the same, greater than 1 or less than equal to negative 1. Period is still 2 pi, right? Because I'm tracking where does the pattern begin. Pattern. And my asymptotes are slightly different. What's the pattern that I would like to the asymptote? On the first one, and then how many times? Pi by 2. And 5 or pi by 2? What's the distance between two opposites? Okay, that's that. You need a break?